In the last video, we talked about solving one-step equations. And in this video, we're going to talk about solving two-step equations. And really what this entails is that instead of having one operation to perform, now we're going to have two operations to perform. And the tricky part with this is recognizing which operation to do first. So just fill out these notes. It says using a combination of what and following the golden rule of algebra, we can solve two-step equations. Using a combination of the properties of equality, which we talked about last time, the addition and subtraction properties of equality and the multiplication division properties of equality. And following the golden rule of algebra, we can solve two-step equations. So let's give this a shot. Now, I like to think of this as peeling an onion, and we want to, again, the goal being to isolate the variable, and the variable being x. So we want to get x all by itself. And I like to think of this as like peeling an onion. We want to work outside in, the furthest away until we get right up next to it. So the first thing we want to do on a problem like this is subtract 3 from both sides. And we are left with 2x equals, and 15 minus 3 would be 12. And now this is a one-step equation. This is the final step. All we need to do is divide by 2. And now clearly, since those cancel, x equals 6. Put a little box around our answer there. And the furthest away from my variable here is this 5. So if we subtract 5, so subtract 5 from both sides, those go away, and we're left with 1/2 times a equals 18 minus 5 is 13. And now we want to use the reciprocal, the multiplicative reciprocal here, which is 2 over 1, which is really just 2, so these all cancel there. I'm going to multiply this side by 2. I'm left with a equals 26. Now for this problem, I have x minus 7 in my numerator and 3 in the denominator. Well, in general, when you have an equation, you want to clear the denominator. When you have fractions in an equation, you want to clear the denominator by multiplying both sides by the denominator here. So I'm going to multiply the left-hand side by 3 and the right-hand side by 3. And that cancels away. So I'm left with x minus 7 equals, and negative 12 times 3 is negative 36. And now I can add 7 to both sides. And I'll end up with x equals, now negative 36 plus 7 would leave me with a negative 29. So for this problem, I want you to try it out on your own first before you follow along with me. The way I want to do this problem, again, I want to isolate my t. I want to get t all by itself. So first I'm going to subtract 8 from both sides. I don't know why I put that equal sign there. That doesn't go there. And minus 8 on the right-hand side. So that goes away. And I'm left with negative t equals negative 5. Now really this is saying negative 1 times t, so I want to divide by negative 1 and divide by negative 1. So I'm left with t equals, and negative 5 divided by negative 1 is a positive 5. Now I also want to solve this problem in a different way altogether. So let me rewrite the original. Negative t plus 8 equals 3. Because I think there should be a fun way to do this, or not necessarily, I would say fun, but there's another way we could do this. Instead of leaving t all by himself and never moving t, why don't we add t to both sides plus t here? So minus t plus t, that goes away. And now on the left-hand side, I'm left with 8 equals 3 plus t. And now if I subtract 3 from both sides, minus 3 here, 8 minus 3 leaves me with 5. And now I have a positive t on the right-hand side here. So now you can see that there's multiple ways to solve each problem. So I want you to get comfortable with knowing that as long as you follow the golden rule of algebra and the properties of equality, you can always end up in the right spot.